Hello and welcome to the Vasthra AI demo video. So yeah, my name is James Ramadurapur. I'm a final year student studying at IIT, and Vasthra.ai is my research project. So basically, Vasthra AI is uh, is uh, a solution that I've created for cultural fashion designers, especially Sri Lankan batik designers, to enhance their designs by uploading a sketch and giving a colored output of what their design is going to look like, right? So there are a few reasons why I chose an idea like this. So we'll talk about the research problem, the research gap, things like that in the future. And we'll also take a look at the code, the source code, and a demo as well. So yeah, the prototype demonstration, the testing, evaluations, and the remaining work conclusions, things like that. So to start off, let's go with introduction. And yeah, so let's talk about batik industries. So batik industries have merely been digitalized. Especially in Sri Lanka, most cultural fashion designers are those who have been doing it like from their family. It's like a family heritage kind of thing, or they do it part-time, right? So digitalization has merely happened to industries like this. So my plan is to uh, give them a new solution with AI. So existing generative AI tools for fashion design exist in the Western countries and in China. They have AI tools for fashion design, but they lack something really important when it comes to cultural clothing. It's the cultural specificity for Sri Lankan batiks. So with those tools, they can create misinterpretation, misrepresentations, and homogenization and cause cultural misappropriation. So because of that, uh, we cannot use those existing generative AI tools. And let's talk about the solution. So the solution is to basically create an AI-powered design assistant to generate culturally authentic batik patterns based on design input, right? And let's talk about the aim and objectives. So the aim and objective is to develop an AI-powered design assistant to generate culturally authentic batik patterns, preserving heritage while enhancing creativity and productivity for Sri Lankan graphic designers. Sorry, Sri Lankan fashion designers. And the significance and the novelty. So why it matters is because it bridges the technology with cultural preservation, empowering Sri Lankan artists in a globalized market. And how to stand out? It's the first, AI tool tailored to batik because it has been attempted in the past. So we can make it an adaptable framework for other cultures to use for their clothes as well. So other cultures, other batiks, maybe other parts of the world, their cultural clothing patterns can be implemented via this as well by different training and all that. So as I said, it bridges the technology between cultural preservation because it hasn't been digitalized. The batik industry hasn't been digitalized so far. So it's a really good chance when it comes to that. So talking about the requirements, let's talk about the functional requirements and the non-functional requirements. So functional wise, we need to submit a sketch, to upload a sketch, and the sketch should be converted into a colored variation, a colored pattern to be downloaded. And non-functional wise, it needs to be highly accurate to avoid all the cultural misappropriation that I said. It also should ensure data security and confidentiality and availability because if this goes to the commercial, if it becomes commercial one day, those are really important things to consider. And we have a user-friendly interface because this tool is going to be used mostly by people who haven't used tools like this in the past. So it should be really user-friendly for them to use as well. And finally, it should provide a good user manual with instructions for them to use it. So let's talk about the architecture. So this is a graphical representation. So to sum this up, the user is there. So the user uploads a sketch to the front end in the upload page. It's sent to the back end where the back end is pre-processed. The image is generated and then saved in the back end and brought to the front for the user to view or download. So this is the basic architecture. So we'll discuss more deeply about the functionalities that are over here, the pre-processing, the generation, and things like that, and the training. So talking about implementation, I used basic tools for this because this is quite a small scale project at the moment. So let's talk about the GAN model. We used Python with PyTorch. which is really useful when it comes to GAN models. So GAN models work with CNNs, convolutional neural networks. So PyTorch was a really good tool when it comes to that. And NVIDIA CUDA was used for hardware acceleration because training takes a lot of time because GANs are highly dataset dependent generative adversarial networks. So because of that, we used NVIDIA GPUs for this. And for the front end, we used React to create a simple web app to make it user friendly for the fashion designers to use. And finally, for the backend, we are going to use Fast API, which is a quick, simple tool that is really good for connecting Python with front ends. Yes, so let's talk about the front end functionalities. As you can see, we have the upload page and the view page. So the user can click this to upload a file or drag and drop it here, and they can select a generator from this selector, and then they can either reset it or generate the design. So if they generate the design, it comes here, and the contrast enhanced sketch is displayed while the generate design is over here. So the user can then either download it or create a new design. So we'll go through a demo as well, and talking about the functionalities of the backend. Uh, so generate and discriminator. So we are going to use a GAN model, a generative adversarial network, for this application. So to give a brief explanation about the GAN model, a GAN model works by two CNNs running against each other, right? So the two CNNs are the generator and discriminator. So how this works is the generator, uh, it generates an image out of noise, out of random noise, and then it shows it to the discriminator. And while the discriminator does it, it gives a feedback to the generator saying that no, this is not correct. You have to change it like this, like something like that. So what the generator does, it learns from the discriminator and it creates another image like that. The discriminator gives feedback continuously. They play a game with each other until the generator is smart enough to fool the discriminator into making the discriminator agree to the image that they have generated. So that is how uh, a GAN model basically works, right? So in this case also, we have a generator and discriminator. So for the generator, we have a unit like structure. So this is designed to map grayscale RGB images while retaining the finer details of the sketch. And the discriminator, which uses a patch GAN. So the patch GAN, what it does is compared with regular discriminators, it takes a look at patches of the image instead of the whole image at once. So when it comes to patterns like batik, it's really useful. Instead of taking a whole look at the image, it analyzes the pattern. So yes, so it classifies the images real or fake based on the patches, right? And additionally, we have implemented the multi-scale discriminator as well, which is used to give a more enhanced version of the sketch to the discriminator. So we look at all those in the code. So yeah, and these initial convolution downsampling. So these are just a few functions that are implemented in the generator. So we'll go through them in the code. So testing the model. So the model was trained, and the training it takes a lot of time. So I did actually a few trials to find the best model that I would use for this project, and I actually the latest one, which included perceptual loss, was actually the best model. So as you can see, I have said that the results show that the generator loss is exhibited steadily, which means the generator is learning. And then the perceptual loss falls, which means that the model is fine-grained style features. So what perceptual loss does is it takes a look at patterns instead of pixels. So like that, the perceptual loss is decreasing as well. So this is basically one summarized log of the final trial that I had. So taking a look at this, we can see whether a model is training or not properly, because GAN models are highly unstable. So during training, things like mode collapse can happen. So mode collapse is when the generator overpowers the discriminator. So like that, things like that can happen, and it can it's not good for the output. So mode collapse, things like that can happen. So yeah, so somehow the final model that I trained, it was okay. It reflects a healthy adversarial interplay, which means it was working really well. So limitations were there, like for example, GANs take a really long time to train. So the very first GAN that I trained for this, it took 30 hours to train on my computer. My computer has a 2060 RTX GPU with 6 GB VRAM, but it still took 30 hours to train an image, to train a dataset with 900 images. So later on, I did a few tricks to reduce that, because I learned that having a huge dataset doesn't work. So we'll talk about the datasets later on. So talking about functional testing, the functional requirements are here and the test cases with the outcomes. So once a batik pattern is uploaded, uh, it gets processed and the output comes. And for validation, if the image is corrupt, the system rejects the file and displays an error. And the sketch, if the sketch is okay, the system returns a colored variation of the design. And talking about non-functional testing, we have accuracy, usability, and security. So accuracy must be there to avoid those culturally sensitive things from happening, to avoid cultural misappropriation. And then for usability, we have user testing, which is also really important, because this system is going to be used by cultural graphic designers who haven't used things like this in the past. So because of that, user testing must be done really well, where the users are observed using the system, and we need to make sure that it's as easy as possible for them to use. And finally, security is also there, because once if this goes into commercial production, there can be data breaches, hacking attempts, so things like that. To prevent unauthorized access, we need to take security into consideration as well. So yes, let's go with the prototype demonstration. Yes, so we can proceed with the image generation demo. So what you can see here is the web app that I have run using the local host. So I have actually run it from my source code over here. So I have run the front end using npm and React, and the back end is an API using Fast API, which is running. So here are a few logs that I have about it. So yes, so this is running, and we can take a look at how it works. So I can either click to upload an image, or I can either drag and drop, right? So for this moment, I'll just select this sketch one over here. Now, as you may see, this does not look like a normal sketch, right? So what this is actually it's a contrast enhanced version of an image, right? So now I've done this to save time, but actually in the future, in the latest release, I will have the automatically I'll have it to automatically convert the uploaded sketch, which looks more this one over here, uh, like this one over here, into something like this. So basically a sketch looks like this, but for the sake of this demonstration, I'll use this one, right? So once I click it, yeah, this one. I'm sorry, let me reload the page. Yeah, and I can select a generator. So these generators are actually different versions of the final model that I have. So generator 3 is my latest model, which includes perceptual loss. Generator 2 doesn't have perceptual loss. So like that, these are like a few generators that I thought were best for the outcomes over here, right? So once I select generator 3 and I click generate design, it takes some time and it generates an image based on the contrast enhanced sketch that I have, right? So this is basically the functionalities. So I can either download the image, as you can see downloaded, or I can click new design and generate something else. So that's basically the demo of how it works, the web app works. So it's been designed to be as simple as possible, to make sure that anyone, even with someone with a really no knowledge, really no knowledge about this digital stuff and websites, can work on it. Yeah. Now, before taking a look at the source code, I thought it would be good to take a look at the dataset, because I discovered that instead of using a huge data set with a lot of different types of images, it is better to create multiple generators from classified data sets. For example, there are different types of Thai batiks which I have used. Now, since I was unable to find a good Sri Lankan data set, I improvised it by Thai data set because they have similar patterns to Sri Lankan data set. So when you look at the images here, now these are like clouds. So these are called cloud motifs. So what I did was I added all these images that look like clouds into one, right? So like this I trained one generator. So this is the generator actually used in generator 3, as you saw in the demonstration before. It came from this dataset, right? Other than that, I also have another one called it's like symmetrical dataset. So for example, the color is also different over here. So this is another one. This is the one that is being in generator 2, right? So like that, if we can create a few more data sets, the user can find the one that matches their sketch the most. Otherwise, it'll be like a lack of options, right? So, but under the time constraint, I was only able to do it for two. So, which are these two over here. So, other than that, the other generator that was remaining, it was used for it was used without perceptual loss. It was quite an old model trained on that same dataset that I showed before, not this one, the other one. So yes, so that's about the dataset. So now we can move on to the source code. So before looking at the source code, let's go to the repository. So I created an organization called Vasthra AI, and in here I have a few repositories. So for example, this implementation one is the one we use today to run the model. The web app is the source code for the front-end user interface. The models one contain a few models that I'm using. So if I go here, as you can see, we have a few models called Gen 1, Gen 2, Gen 3, like that. So these are all different variations, like work in progress models that I had to implement here. So the Gen 5 is the latest one. I probably have added more later onwards. So that's about that. So the instructions to train these models are there, as well as the information about the models are there in this markdown file as well. So including the generator, architectures and stuff, everything is there. And yes, so that's about the repository. So you can go to github.com slash VasthraAI and you can find it. So yeah. Next, we'll go to the source code. So as you can see here, we have the web app contains the front end. So in the src folder, under the constants and the components, we have upload and view design, which I use to handle the uploading and view design part. So file handling and then error handling are all implemented as well to avoid irregular types being uploaded, etc. So yes, so that's about the front end, which is not that important. And then we have the API. So API is what controls the front end and the back end, which passes the uploaded images to the generate files, and then which brings them back to the front end for downloading. It's all done by this API.py file. So that is the one that was running over here. So this one right here. And let's go to the model. So the model is the most important part of this. So yes, so let's take a look at the main file, which is the sketch to image get. So this is actually the model architecture that is used for training, right? So in here we have residual blocks, the generator and the discriminator, the multi-scale discriminator, things like that, right? So let's take a look at these one by one. So in the generator class, we have initial convolution, downsampling, residual blocks, all those things. So in the initial convolution, what it does is it extracts the low-level features from the sketch. Uh, it captures a broad texture with strokes for idealized, it's really good for, it's really ideal for batik because, batik is a kind of stylized art. And next we have downsampling, which reduces the spatial size and increases the depth of the image, so it helps capture global shape and pattern layout. And then we have residual blocks. So what residual blocks is this? It allows deep feature learning uh, without vanishing the colors and the gradients, right? It's really good for batik variations, right? And then we have upsampling, which is used for uh, restoring the resolution back to original. and then we have the output layer as well. Other than that, we have an attention module for spatial attention. So that's about the generator. And if we come to the discriminator, we have four layers, and the four main layers, which are used for uh, the four layers are used for, with the patch gun to take patches of the sketch, to patches of the image, and instead of the entire image, and find that every region is captured. So it's really good once again when it comes to batik designs, because instead of an image, it's a pattern. And also we have a multi-scale discriminator. So what this does is it sends a downscale version of the input sketch to the discriminator over here. So what it does is it's really good for the model to judge the finer details at the original resolution and give a broader, structure and global consistency at the smaller scale. So it is really good when handling batiks because the patterns are really delicate. Now all these decisions that I've taken to include a multi-scale discriminator, give it spatial attention, and then output layers with upsampling, downsampling, residual blocks, all that, it's all there for, it's really good when it comes to batiks, because batiks is a kind of pattern art, and all these options do a really good job at identifying these patterns and things like that. So this is the sketch to image GAN, and after that we have the data loader, which is the train sketch GAN, and from the data loader it goes to the training script, which is this one over here. Now what this training script does is it trains it based on the architecture in the uh, sketch to image GAN.py, this one. So we have the hyperparameters, high number of epochs is good for a GAN model, and then batch size is set to 4, which is not too big, not too small, because if we increase it even more, the CUDA runs out of space, runs out of memory, which makes it really hard to train the model. And the learning rate is set to a really, really low value, because when it comes to uh, GAN models are really unstable when training. So because of that, a learning rate should be really, really low, right? And after that, we have taken three loss functions into consideration. The first one is adversarial loss, which, and then the pixel loss, which is L1, and finally perceptual loss. So the adversarial loss is used to teach the generator how to be the generator, so like how to fool the discriminator. So that's what the adversarial loss does. And then the pixel loss is used for pixel-wise differences, and it keeps the generated image aligned with the sketch. And finally, we have perceptual loss, which is the most recent addition to this training script. So what it does is it uses VGG19 to compare the deeper features, and it encourages higher level visual similarity, like batik style, flow, and structure. So basically, perceptual loss is like, think like it. What it does is it looks at the pattern instead of the pixels. So when it comes to GAN models, I'm sorry, when it comes to batik images, it's really, really good because it takes a look at the pattern instead of the pixels, right? And when it comes to training, we have the discriminator training, and then the generator training. So separately, so what happens is when a generator is training, the discriminator starts training first, and then it stabilizes the GAN training and avoids being overconfident. And then after the discriminator has trained one cycle, the generator starts to fool the discriminator. So it stays close to the real image and preserves the visual style. So like that, its training happens consistently, like that. It's a parallel training process, right? So this combination is a great way to work with batiks. So in the meantime, we have checkpoints every 5 epochs, which exports an image accompanied with the sketch, and every 10 epochs, a PTH file is saved for the model progress. And once the training is completed, a PTH file is saved for the model. So this generator 1.pth is the one that was created when this model was trained, right? And after that, we have the generate script. So this is the script that is in charge of generating the image based on the sketch, right? So what this one does is initially it transforms the image into a grayscale, it normalizes it, and then yes, it uses ensemble, down here to add some noise to the image to create variations. And yes, so that's how the image is created. So once it's created, it's saved in this generated image folder over here. So it's saved with the timestamp, so it's easier for the model to access it, the API to access it and send it to the front end, right? So that's how the generate function works here. So initially I created it to work as an argument. So that's about the source code over here. So thank you so much for watching this video and hope you had a good idea. So if you have any inquiries, you can send an email to my email address. It will be in the description. Also, all these models and source codes are available in GitHub as well. So if you want to implement them or see how they work, you can go there. Also, if you have any ideas on how to update or upgrade this, make sure to let me know. So yes, thank you so much and have a nice day.